Welcome back. Problem 3-42. So statement is two solid shafts are connected by gears as shown. Knowing that G is 77.2 gigapascal for each shaft, determine the angle through which end A rotates when TA is 1200 Newton into meter. So you can see these are the two shafts that are connected through this gear B and C and B. At the end of this shaft there is a torque TA, which is 1200 Newton into meter, is applied. This end D is fixed, so you have to find the angle through which end A rotates. So this rotation theta A will be equal to angle of twist in shaft A with respect to B plus the angle of twist of point B, which we'll see in a while. So let's start with the solution. So first step is that you can see that this gear B will apply a force, horizontal force on this shaft in this direction, and this will be the circumferential contacts. So we will first find, we have torque TA and we will find the torques in this shaft CD. So how we will find it? So calculation of torque, I will write calculation of torque. So first we will find the circumferential force. This force is F. So this force, you can see this force in shaft in gear B will be equal to TAB divided by RB, and this force is same exerted on this gear C, which will be equal to TCD divided by RC. So from here you will get TCD. So TCD will be equal to RC divided by RB into TAB. So we have TAB is given as 1200 Newton into meter. So we'll put the value 1200 multiplied by RC. RC is 240 millimeter. So just put the value 240 is 0.240 meter divided by RB. RB is this 80 and 80 is 0.080. So when you calculate it, you will get torque in shaft CD are applied on gear C is 3600 Newton into meter. Now we will find the, as this torque is applied on this gear, which will be in opposite direction, it will be in this direction, which will cause angle of twist between shaft C and D. So we'll calculate the angle of twist of C, point C, with respect to D, which is equal to TCD into LCD divided by J into JCD. So TCD is available, which is equal to 3600 Newton into meter. Length is also given, LCD is 1.2 meter. Clear? G is given as 77.2 gigapascal, so 77.2 into 10 raised to the power 9, and J for this will be equal to pi by 2. This is diameter D. D is given as 60 millimeter, which is 0.060 meter. So C will be equal to D divided by 2, which will be equal to 0.030 meter. So pi by 2 C power 4, so 0.030 power 4. And from here you will get J will be equal to 1.2723 into 10 raised to the power minus 6 meter power 4. Now you have all the values. You can just put in this formula, angle of twist of point C with respect to D. So TCD is 3600 multiplied by length is 1.2 meter divided by G is 77.2 into 10 raised to the power 9 multiplied by J, which is 1.2723 into 10 raised to the power minus 9. This is minus 9. Okay. So when you calculate it, you will get angle of twist of point C with respect to D will be equal to 43.981 into 10 raised to the power minus 3 radian. and you can also call it angle of twist of point C. Now this angle of twist of point C will be this, will cause it to move to new point C dash. Clear? So we can convert this angle of twist into linear circumferential distance by using formula S is equal to r theta, and both of these two gears will move same circumferential displacement. So we will write it over here. Okay, so circumferential displacement at contact point of gear B and C and B, and that will be equal to, we know that this is formula S is equal to r theta, so this is the circumferential distance. So we will write RC into theta C is equal to RB into theta B. So from here you can calculate theta B will be equal to RC over RB into theta C. So RC is given as, so RC is 0.240 meter. It is 240 millimeter, and in meter 0.240, and RB is 80 millimeter, so 0.080. Multiply by theta C, which we have calculated this 43.981 into 10 raised to power minus 3. So when you calculate it, you will get theta B angle of twist of point B will be equal to 131.942 into 10 raised to power minus 3 radian. So it means that this point B or gear B will move this distance. This angle will be theta B. There is twist in this gear. Now we will also calculate twist in shaft AB, because there is torque at point A, so twist in shaft AB will be equal to theta A with respect to B will be equal to TAB into LAB divided by G into JAB. So put the value TAB is given as 1200 Newton into meter. 1200 multiply by the length. So you can see this length is 1.6 meter. So 1.6 divided by G is 2277.2 into 10 raised to power 9. Multiply by J is pi by 2 C power 4. Now we will see this is 42 millimeter. So C will be equal to 42 divided by 2, which is 21 millimeter, and 21 millimeter is 0.021. Okay, 0.021 power 4. So when you calculate it, you will get angle of twist of point A with respect to B will be equal to 81.412 into 10 raised to power minus 3 radian. Now rotation of A. Now rotation of point A or A will be equal to theta A, and it will be equal to angle of twist of point A with respect to B plus angle of twist of point B. So put the value theta AB is 81.412 into 10 raised to power minus 3, and theta B is 131.942 into 10 raised to power minus 3. So when you calculate it, you will get it 213.354 into 10 raised to power minus 3 radian. And we know that 2 pi radian is equal to 360 degree. So 1 radian will be equal to 180 degree divided by pi. So multiply 213.354 into 10 raised to power minus 3 with 180 degree divided by pi. So you will get angle of twist theta A will be equal to 12.22 degree, which is the answer. Because you can see that this due to angle of twist in shaft AB plus the angle of twist in gear AB, which is equal to theta A. And that was all about this problem 3.42. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about every latest video which I post. If you have any question, you can ask me in comment section. Thank you for watching.